And we're live! Welcome to RockSim Live. I'm Tim Van Milligan. This is where we talk about RockSim, RockSim Pro, and the Launch Visualizer. It is Friday, January 30th, 2026. So thanks for joining. And hopefully my phone's going off. Just make sure it's nothing important. No. Anyway, welcome to RockSim Live. I do have the chat going on, so if you have a question on RockSim, this is where you ask it. Let me bring up my screen here as soon as I get to our Apogee website. Let's see, computer screen. There we go. All right, so this is the Apogee website. Let me make it a little bit bigger so you can see it. I'm gonna have to turn this off. My daughters are texting back and forth. I said, where am I? Yeah, so this is where you get RockSim. It's apogeerockets.com. Is our website. You'll see there's a banner up here for RockSim 11. Then there's one for RockSim Pro that you can try for free with a $30 order. So just place your order and we'll give you a free trial. It's worth 30 days. And if you want to do it again, we can extend it again with another $30 order. So you don't have to buy RockSim. Just buy your rocket parts from us. Your parts and your motors and your kits and your books and building supplies, glues. We're here to help. So we have Carlos from Marietta, Georgia. I haven't seen him in a while. He says we are between storms here in Marietta. And we have Hood News. He is in Aurora, Colorado, which is just like right up the road. And he's saying, I'm here, Aurora, Colorado. Oh, wow, lots of laughs. Ran over by a car. Sup, Tim? Take care of the ladies. Yeah, I'm taking care of my daughters and my wife. So if you are new to RockSim, you came to the right spot. I'm here to teach you all that you need to know. If you click on the How-To and Guides menu and then come down here to Software, you can get more information about the software. You can get some of the starter video tutorials, and I recommend people start here. It's just a bunch of video tutorials, and I just start with number one and work your way down. The first thing that we want to do is to open up RockSim, open the design, and launch a rocket, because until you're launching, you're not getting the full benefit. So we want to get you up and running as quickly as possible by launching a design. Then we're going to take a look at the flight profile. In the RockSim Pro, we call it the Launch Visualizer. Just seeing where the rocket is in the real world can give you a lot of information. So that's what we want to do there. Changing our units, zooming in out with the 2D control, customizing the 3D view, modifying preferences. There's all kinds of good things. And then there's some additional ones. If you go to How-To Guides, Software, and there's RockSim Pro video tutorials. Basically almost the same thing, doing your first simulation, but how to work your way around in the 3D environment. Because you're going to be in a 3D world and you want to be able to manipulate the world to be able to look at the rocket from any view. There's a number of different views to look at. So that's all kinds of good stuff there. What else can I tell you about that? How-To and Guides, Software. Here's the RockSim Live training. That's what we're doing right now. You can purchase it here. There's system requirements. We had somebody that emailed today. They were getting a weird error, and I kind of think my I'm sensing that they're not running on the right system. They're running on an old system. So if you want to check those system requirements, you know, Windows 11, Windows 10, I'm not even sure it's running under Windows 10 anymore. It's so old. On the Mac, we have verified it's running on Tahoe, which is OS 26. They jumped from like 15 to 26. I don't know what was all in between, but it does run. That's what I'm running on my Mac. Here on this one, actually, I think I'm on 15 about my Mac. I am on 15.7.2 on this particular computer. But it does run on the latest one. We verified that. It runs just fine. No issues. Okay, any questions? We got some people here, but nobody has any questions. So last week, we had a question that I didn't get to because it came in so late. It was, how do you do sub-assemblies in RockSim? So a sub-assembly is kind of like sub-assemblies are internal inside the rocket. So we created them for things like E-bays and engine mounts that you want to move from one design to another. So let's open up a design and create a sub-assembly, and I'll show you how to use it. I gotta go here to RockSim Designs. I don't know. Let's go to Auto Production Kit, see what's in there. Blue Shift. I don't know what this one is. Let's see how big it is. See if it's big enough to have a 1.3 inch in diameter. Yeah, it's big enough. But 1.3, what diameter is that? Is that a BT55? Anyway, we'll say that this motor mount back here, we want to turn it into a sub-assembly so we can create a new design and just bring it in. As I was explaining last week, sub-assemblies is kind of the hard way to do things, but it is possible. When we first created sub-assemblies, is we thought people would use it a lot, and then people didn't. So we kept it around, but it's kind of awkward to use. So first we're going to go here to our design components, and we need to find this part right here. So I can click on it, and it can bring up, here's the engine mount tube. So what's associated with this engine mount tube? We have an engine hook. We have an engine block. Oops. Save your changes? No. And these centering rings are not associated with the engine mount tube, because if I collapse the tube, there they are. They're like one level above. So we're going to create a sub-assembly. We're going to move all these parts into the sub-assembly. So first I'm going to start here with this body tube. So I'm going to attach the sub-assembly here. So I'm going to come over here to the sub-assembly button. Can everybody see the sub-assembly button? I got to look at this screen here. Yeah, it's not covered up. So here's the sub-assembly. You're going to click on that. Is the new sub-assembly owned by the selected body tube? I'm going to say yes. So the sub-assembly owns it. So that's why if you look over here, it's nested underneath. So it's indented. It's not straight underneath. So the sub-assembly is owned by the body tube. Okay, so the first time you own the sub-assembly, it kind of looks weird. So what's this thing? So it's called sub-assembly. We got to name it. So we're going to call it a BT55 engine mount. I think it's going to be 18 millimeters is the motor diameter. And so that's all we're going to do right now. we're just creating the subassembly. Now we're going to load parts into it. So we're going to click OK here. We're going to come back to this because we haven't saved it yet. So, so now we're going to start loading parts into the subassembly. So if you notice, if we highlight the subassembly, all the buttons are active. So we can start adding parts into that subassembly. So, so the first one I'm going to add in is the centering ring. So I'm going to do a copy of that part. I copied it, so now it's on my clipboard. Then I'm going to come up here to subassembly, and I'm going to right click with my mouse. You can also go to the file menu here at the top, but I'm going to go to just, highlighting this and do a right click and then hit paste. And you'll notice that forward centering ring is now pasted there. So now we actually have two of them in here. So I'm going to get rid of this one. So I'm going to right click on it and then hit delete. And it's going to ask me, do I want to delete? And I'm going to say yes. So now we have the forward ring in the subassembly. I'm going to do the same thing with the aft ring. So I'm going to highlight it, right click on it, select copy. I can also do a cut. And then come up here to subassembly, right click and select paste. And you can see it pasted it in. So now we have two aft centering rings. I'm going to just delete this one. Delete and say yes. Okay, so now, what is this? Forward. Okay, so these rings are now attached to the subassemblies, and I'm going to take the engine mount tube. Now this one has parts attached to it. It's got an engine block and an engine hook. When I do a copy, it's going to copy everything that's associated with this. So it's going to copy those as well. So this time I'm going to right click, and instead of copying, I'm going to do a cut. And cut and copy are the same things, except cut actually copies everything to the clipboard, and then also at the same time it deletes it from where it is. So that's what cut does. So I'm going to cut this. It's going to ask yes. I'm going to delete it. Then I'm going to come up here to subassembly, then right click, and then paste. And you can see it pasted that engine mount in there along with the engine hook and the engine block. So now we have a subassembly of just all those parts. So now I'm going to come back here. So the first time we created the subassembly, so it's kind of like a file folder. We're just throwing parts into it. So now we got to save this. So now I'm going to open it up, and I'm going to say save parts to a file. So it's going to ask me where I want to save this. I'm just going to throw it on my desktop so I know where it is. So then I'm going to say engine mount. Okay, you can't see engine mount BT55 sub-assembly. So I just know what it's called and hit save. So now if I go to my desktop, here it is right here on my desktop. So we've now saved it to the desktop. Okay, so now what do you do with it? So at this point, I'm going to hit OK, and it's saved everything. So now I'm going to start a new rocket design. So I'm going to go here to File, New, and I say, do I save my changes? And I'm going to say no. And now I'm going to start with the BT55 tube. So now we're going to design a rocket. So we're going to start with a nose cone. And I'm looking for a BT55, which is a PNC 33. 1.32. Okay, so that works. So we got a nose cone. It's hollow. And click OK. Now we're going to select a body tube, and it's going to be another BT55. Okay, so we've attached the tube to the nose cone, and it's 18 inches long, which I don't care. So click OK. All right, so now Now we can add that engine mount. So now I'm going to go to sub-assembly because I want to load in that sub-assembly. And I say, is the new sub-assembly owned by the selected body tube? I'm going to say yes, because the last time when we saved it, it was attached to that body tube. So I'm going to say yes. And so it brought up the sub-assembly screen. And what I want to do is now, instead of saving parts to the file, I'm going to load parts from a file. And so now I'm looking on my desktop. I'm going to sort by date. And you'll see my engine mount BT55 subassembly, and it's got an extension RSA, which stands for RockSim Assembly, or RockSim Sub-Assembly. Either way, we're going to select it, click OK, and then boom, it added it into there. Except it moved one centering ring over here. So that's interesting. So let's take a look at that. So I'm going to, okay, I did highlight it. That's the forward centering ring. So now I got to do a little tweaking here. See, the last time, if I would have gone back to the other design, it was a shorter body tube, and that centering ring was referenced from the front of the tube, because that's what I can tell it from here, instead of from the back end of the tube. It should have been from the back, and we wouldn't have had this problem. But I can quickly change it just by taking this and sliding it over to there, which is approximately the location I want it. This time I'm going to say from the base of the owning part, and everything's okay. So now we've added a whole bunch of parts. We added 1, 2, 3, 4, 5 parts really quick. And that's the purpose of the subassembly. So now I can go back to my body tube, and I can add some fins. So I'm going to add some custom fins. And whenever you add a new part, it always looks in the database. So I'm going to say cancel out of that. This is my fin design screen. And I'm going to go here to data points, plan points, and then just start moving things around to make a fin the way I want it to look. I think I'll add a point over there. Maybe another one here. Maybe I'll do this. That's a funny looking fin right there, but I like it. So we're going to click OK. So now this needs a parachute and a shock cord. So I'm going to add a parachute here. Here's parachute. And let's add an 18-inch nylon and put it right here. We're going to move it back to about there, which should be in the tube, and click OK. Now we need to add a shock cord. I'm going to cancel out of the database, and then over here from the classification I'll choose shock cord and then select my material. Let's see, 1/4-inch flat elastic, I don't know, 36 inches. Right now my shock cord is right there. It's a mass object, so it doesn't have a shape, so it uses a circle. And I'll just move it back down to here and click OK. Let's give it a launch lug. So select the body tube, come down here to launch lug. We're going to choose, this time we are going to select from the database. We're going to get a 1/8 inch by 1 inch long launch lug. You can see it put it right there. So we're going to change the location. You want your launch lugs. I'm going to have 2 launch lugs. So I'm going to call this the forward launch lug. Forward launch lug. And if I looked at this from the base, you'll notice that it interferes with the fin, so I need to move it around. So to do that, come here to radial position, and you can take this wheel and slide it, and you notice that this is sliding around. I want it at exactly 60 degrees, so I'll type in 60 and hit the tab. You can see it popped over to the 60-degree position. Click OK. So now we have the forward launch lug, and I'm going to do a copy. Come back up to the body tube, paste it. It added another forward launch lug, and it added it in the same position because basically we copied everything, not only the dimensions of the lug, but also its location. So I'm going to edit that now, and I'm going to go back to a side view, and now I'm going to change the location. I'm going to put it down here near the bottom. I'm going to change the reference to the base, so now it's measured from the bottom of the tube. And then we're going to change the name. We'll call it the aft launch lug. Click OK. And if we look at it in 3D, there is my launch lugs. My nose cone is kind of translucent, or is that gray? Let's see what the color is. It has an opacity of 0.12, so that's why it kind of looks grayed out. Let's make the opacity 100%. So now it should be orange. Let's change it a little bit so we can tell it from the tube. Click OK. And there it is. So there's my rocket design with the sub-assembly. This works on both RockSim and RockSim Pro. I am in RockSim Pro right now. Let's run a simulation with this. So we're going to go up here to the Prepare for Launch button, which is that one there. We're going to select our engine mount tube, choose an engine. Let's choose an S2C6 5. It's hanging out the back by 1/2 inch. Click OK. Flight events, deploy the parachute at maximum ejection delay. Starting state, it's on a 48-inch long launch rod. It's 0 degrees from vertical. So the azimuth angle doesn't really matter. The azimuth is your compass direction. North is up here. East is over here to the right. South is here. West is that way. But since we're launching straight up, no matter what compass direction, doesn't matter because it's always straight up. Now, if you angle it, now it matters. Under launch conditions, let's choose the launch site. I don't know where this one is. Fox Valley Rocketeers. Click OK. It's 247 feet above sea level. Here's the latitude and the longitude location. We'll see that in just a second. I'm checking my wind. This shows wind. How to read this table. It tells me at 0 feet above sea level. Remember, we're 247 feet above sea level for a launch pad, and you can see that here under launch conditions. But at sea level, we have a wind coming from the -90 direction. So -90 is out of the west. It could be 270 or 90, -90. It's the same direction. If it was a positive 90, it would be coming from the east. But at 0 feet above sea level, it's blowing at 8 miles an hour. And then at 12,000 feet above sea level, it's also blowing at 8 miles an hour. So what we've done here is we set a constant wind, no matter what altitude, from 0 to 12,000 feet, it's all blowing in the same direction at 8 miles an hour. If I were to change one of these directions, if I make it 180 here, now at 12,000 feet, the wind is coming out of the south at 8 miles an hour. So it's blowing to the west down here and blowing to the north, coming out of the south, blowing towards the north at 12,000 feet. So that's what this chart means. And you can save this wind table to a database, so you can call it up other times if you want. And then we'll run a flight profile just to see what this looks like. And it says you must save your file before running the flight profile. So it's going to ask me where I want to save it. I don't know what we're going to call this, the January 30 rocket. So that's the name. Hit save. Threw it on the desktop. And now it's loading the launch visualizer so we can see this launch. It's still loading all the maps and stuff so you can see our launch pad. It's in the middle of a grassy field. looks like it's a soccer field. These rings right here are the sprinkler system. We got a parking lot over here, roads over here, some buildings over here. Let's see if we can figure out what kind of buildings these are. That kind of maybe a water treatment plant right here. You can kind of see the green algae. So our rocket, where was our rocket? Right here. So water treatment plant, I don't know what this is, if this is a school or not, but okay, so we're going to launch it, and we can tell right here that the rocket's going to be in the air for 33.71 seconds. So when we launch it, you can see the smoke coming out. Now the smoke has stopped, so the rocket is coasting, and we can kind of see down here. This is called the mini view, and we can zoom in and out of the mini view. And then the rocket is drifting back down to the ground, and it's going to land there. So here is the compass. So I need to swing the black arrow so it points upwards, which is north. So now we're looking at the launch again. So north is now at the top of the screen, and you can see the rocket as it's taking off. I'm trying to zoom in here, and it's a little jittery. It took off, and it kind of arced into the wind to the north, and now it's falling back down to the south. And it landed in that batch of trees right there. So not so successful of a launch, but so if you wanted to change something, you'd probably say, okay, we need to angle this rocket. So if we got a wind coming out of the west, it's always going to be blowing this way. So I would probably have to arc it really far to keep it out of these trees. So let's see. Anyway, let's see if there's any other questions. Hood News says, does the sim take into account the active weather? And if not, how do you import the weather? Good question. Okay, so it doesn't take into account the active weather. So you do have to import the weather. So how do you do that? Well, first you need to find your weather. So let me open up a new website. And I'm going to go to a website called windy.com. And this is windy.com. My question is, where was that launch site? What state was it in? Do you know? This is going to be hard to find. Let me see if I can, let's see if I can find it. Let me open up a new tab. And it says AI mode. Okay, ask me anything. Okay, so I am going to ask it anything. And what I want to ask is, where is that launch site? So let's go to prepare for launch. Under launch conditions. Okay, so let me move this over to here. And so here's my browser. And it's like, where is 44.292700 north minus 88.43980 west? Thinking. Appleton, Wisconsin, specifically the neighborhood of Grand Chute. Okay. So let's see if I can copy this. Now, where'd my Windy go? Oh, it was on this one. Okay, it's on this tab. So here, we're going to go Appleton, Wisconsin. and hit enter. Okay, there it is right there. Oop, zooming in. I lost it. There it is right there. What is this stupid thing here? Okay, so currently we have a 9 knot wind coming out of, you can kind of see that arrow right there. It's not coming out of the north, although they're calling it north. We're going to call it northwest. So let's call it like minus, I don't know, 10 degrees. And it's 12 degrees Fahrenheit right now. Let's see if we can change the wind. And somewhere here, altitude. Okay, so that's the surface. And at 100 meters, look at this. Let's go to 2,000 feet. At 2,000 feet, the wind is at 15 knots, same direction. So what did I click on there? Okay, so it was 9 knots towards the ground, 15 knots, and that was at 2,000 feet. So we're going back here to my wind table. Okay, so this is, the ground level was 247 feet, and it was, what do you call it, minus 10 degrees. And what did we say the speed was? 9 knots. I don't know how many knots are in miles per hour. Where'd that windy go? Okay, so here I'm going to say convert 9 knots to miles per hour. This is what a good AI is. So it's 10.357. So going back here, 10.357 miles per hour. And at 2,000 feet, same direction, minus 10. And it was 15 knots. So I'm going to say, okay, convert 15 knots to miles per hour. 17.262. It's a little breezy up there. 17.262. Okay, so now we've adjusted the wind. So under launch conditions, we also need to adjust our temperature. What did we say it was? 15 degrees? Let me go back to that website. This is, we'll call it 12 degrees. 12 degrees Fahrenheit. And we can also probably from this website get barometric pressure, I'm sure, maybe. Radar, wind, rain, thunder, temperature, clouds, rain accumulation. Let's see, do they show barometric pressure? Pressure, look at that, right there. 30.54 inches of mercury. So come back over to here. We got to make sure that this is in inches of mercury. What did we say it was? 35? 30.54. 30.54. Temperature 12. Humidity. Oh, let's see what we got for humidity. Here's humidity. 65%. 65%. Okay, so there we go. So now we go flight profile. Now we're going to see this one. So we've just imported the weather conditions. So it took a little work, but I mean, that wasn't more than a couple minutes. So spin this around here. So now my wind is coming from this direction. So kind of following the weathercocking cone. That what you're seeing there is a weathercocking cone, and it tells me, you know, if the rocket is weathercocking too much. And we launch it. The rocket's going up. And again, this time it's not in the air as long. So it probably did not go as high. And we can zoom out and we can see this time, okay, so we didn't land in those trees over here. But we landed in, are they trees here? Yeah, we landed in these trees. We found the trees again. All right, well, that was cool. So now if you want to compare these two launches, close this. So the first one went 500, no, that was maximum altitude. That was only about a foot difference. But it stayed in the air longer this time. So if you highlight both of these together and you come here to the launch visualizer, the flight profile, we can display both launches at the same time. So what we're seeing is two rockets on the same pad. Let me turn off the weathercocking cone. Okay, so here's the rocket right here on the pad. Remember, one rocket landed here, one rocket landed there, but when we launch them, you'll see. Okay, so now we are seeing two rockets, and they crisscross in the sky. One's going to go land over here, and then the other one's going to land down here in these trees. And basically the difference was wind. Let me get it to the end. Okay, so now we're comparing two launches from the same spot with different wind conditions. How cool is that? I love that feature. That's just like the coolest feature. All right, so that was cool. And he says the black and white logo, BMW logo, is your center of mass. And yes, that is the center of mass. Let's see if I've got to get this on the screen. So that is the center of gravity symbol. And BMW must have chose it for their logo because it's been around since like the Wright brothers. I think. We could ask the chat. Yeah, we can ask the chat. That's not. Where'd that other window go? It's probably behind here. There it is. When was the first CG symbol used in aviation as a circle with a cross in the middle? Let's see what it says. Searching. The 1920s to 1930s. So when was BMW created as a company? Let's see who had the symbol first. Okay. Water treatment. It would be really cool if it could import current or forecasted weather from the National Weather Source of some source. That's from D. Hagen, 6278, and I certainly agree. We looked into it, but the data is not free. So importing that data would cost money, and right now not enough people are buying the software anyway, so we're going to hold off on that for a while. You know, if you want it, you know, you got to, as the saying goes in aviation, no bucks, no Buck Rogers. Pretty sure there's going to be an online source that can pull up database based on a zip code. I'm sure there is too. And he says, you're doing a great job. Best time I've ever had on YouTube. Well, there you go. We are the best. David H. says, I was on last week asking about my Launch Visualizer account not being able to upload new models. You said to email you with a problem and you would provide a solution. I still have not received. Oh my goodness. That's bad news. Okay, so what you do in this case is kind of like go to the contact form on our website and then go here to Launch Visualizer questions. So these questions, they go to different people. Order inquiries goes to our orders department, and pretty much everything else goes to customer service. But when we know what you're looking for, then we can reply. So basically the person either did not get the email or the email got lost, but it did not get forwarded to me. So I apologize for that. Try it again. Say, can you forward, and you could put that in the message, say, can you forward this to Tim? And then I will personally take care of it. And he says, he tried to contact multiple times, no joy. Oh my goodness. I don't want to put my email out in the general email. But so the best way is that contact form. But just say, can you forward this to Tim? And maybe somebody, in fact, do it to order inquiries. I think that one goes to me. Or it goes to a person that monitors their email more often. Okay, I'm looking for questions. Carlos K. says, I fell for a vendor's holiday mystery offer and ended up with some oddball motors. Is there any way to search RockSim for my rockets that can use an A10 PT or any other motors? Well, the A10 is technically in RockSim. So that's a 13 millimeter motor. I'll show you another thing on, okay, well, let me go I'll do RockSim first. So you're searching for a motor. So you go here to prepare for launch, and then come down here, it doesn't matter what rocket. It doesn't matter which rocket. So whatever rocket you have open, go to the engine mount and say choose engine. And then under the diameter filter, and say show all engines. So under manufacturer filter, it should show all. And under the diameter filter, it should say show all. And then you can use the search engine code box right here. So I can go A10. And as soon as I type in A10, there's the A10T. And you got a PT. So P means plugged. So the ejection delay right here, it actually is a plugged motor. So I have now loaded an A10 plugged T motor. And Estes uses T, nobody knows what the T stands for, but everybody kind of thinks it stands for tiny because that's the smallest Estes motor. So I've loaded the A10 PT in there and I click launch. And you'll see right up here, it says A10 TP, but in reality, the P would go in front. No, this is the right nomenclature here, but that's the A10. So you're probably wondering, okay, I got a motor. What rocket can I fly it in? And I think we have a tool for that. Go to rocket motors. Where is that tool? I always lose the comparison chart. How to use the sortable table. Let me go to Rocket Kits. Go to Shopping, Rocket Kits. Okay, sort kits by motors. Okay, that's what I'm looking for. Okay, so to find out what rocket kit uses a specific motor, follow these steps. From the drop-down menu up below, select the rocket motor you have in your personal inventory. So first you got to find it. So again, you can type in A10, and this is going to be a 0-second delay. And then it pulled up all the kits that can use a 0-second delay. Now you have a plugged motor. A plugged motor in a rocket means you're going to have to use electronics. So that is a motor that Estes actually developed for, they had these things called drag racers, and they went along the ground. So instead of going up in the air, they went sideways. And so they were in a car, and when you're in a car, you don't need an ejection charge, which is why it was plugged. So you got, unless you need a plugged motor, yeah, they took you. They took you for your money. But you can use this for anything. So, you know, like say I have a Cicerone F36. And as soon as you choose that, these are all the kits on the Apogee website that you can use an F36 Cicerone. And you can kind of, you know, like pick one. And what I would do is say, okay, you know, what size rocket would that F-36 fly in? Well, if we know it will work in the Mako, if you have a rocket that's approximately that size, just looking at it from, you know, size perspective, you could probably fly it in that size rocket. But then you would also want to double check it in RockSim. So now, like if I open a design, and if I go to designs, let's see if we got a Mako in here. Nope, because the Mako is pretty new. So what I would have to do is to go to the Apogee website and download the file there. So here, I'm on the Apogee website, come here to RockSim file, click on that, and it's going to jump you down to the bottom. And then you can say the free RockSim design file, and it's downloaded it, and the Mako was downloaded. If I click here, it'll open up the folder where it's located. I'm going to open that up, and now it created a folder, and I'm going to drag that into my applications. I'm just trying to put it into the same folder as everything else, so I know where it is. RockSim 4.3 designs, Apogee. I'm going to take this and drag it into here. So now, if I go here, Mega Mako. Did I download? No. There it is, Mako. And then I can open that. I'll just drag it onto RockSim, and it should open it. Save my changes to that one. Sure, why not? And then it opens up a Mako. And there it is right there. So now we want to check to make sure that F-36 is going to work. So choose an engine. This time I'm going to say F-36. And there's two versions. and I don't know which version this is. This one has more total impulse than this one, so we'll use the smaller one, which means it has less gas in the tank, is what that total impulse number is. Kind of a relative, how much propellant is in the motor. The bigger the number, the more propellant. So let's call it 11-second delay. And we're going to launch it. Let's see the flight profile. Remember, we're launching from Appleton, Wisconsin. On a cold, windy day. No Bucks, no Buck Rogers. I'm using that every time I get my W12 Audi. Tried to contact multiple times. Does RockSim Pro have a way to specify an ideal landing zone and run multiple simulations, varying the heading and the launch rod to find solutions? That's from D. Hagen. And the answer to that is yes, it does. Okay, so here I'm just running this simulation with the F-36 and just seeing what that trajectory looks like. It looks like it's going nice and straight. That's the most important thing. Then it's coming down. The parachute has not opened yet, so my delay is a little long. But then it finally opened, and now it is coming back down to the ground. And this time I avoided the trees. And this is kind of a fun, it made an R in the sky. I've never made an R before. So why did it do this? Well, because as it was coming down, it was trying to weathercock into the wind. Or actually, no. It was doing something weird. Anyway, but that's what it was. Okay, so let's answer that other question. So where do you get that? So you say this is the hard part. We got 7 minutes to do it in. Okay, so on my computer, I'm opening up a program called Google Earth. And Google Earth is a free program you can download from Google. I will just let you do a search for it, but you would find it and you would download it. And basically it is a globe. It's kind of like what RockSim Pro does. And so we were in, oh, there's Appleton. Okay, so now where's that water treatment plant? Does anybody see it? There's an airport. We have to go back to RockSim. And where is that other? No. That's why I got to get my coordinates again. So prepare for launch. Launch conditions. So here's my coordinates, -42. I'm going to just slide them right over to here. And then in Google Earth, I'm going to type in 42.292700 north, -88.4398 west. Search. And it searched, and it must have found it. Where is it? We couldn't understand this location. So I'm doing a visual search. Oh, I think I found it. Let's see, where's north? Does anybody? This kind of looks like it looked like that other building. let me put a pin here. So latitude, okay, so let's go 42.292700, and then minus 88.4398. Okay, so it moved. Where is that thumbtack? Come on. I know you're there somewhere. We're pretty close. Let's see, we need 42. So, ooh, it's further down this way. 43, 43. I'm looking at this number while moving the thumbtack, and I'm comparing it to this number up here. 42.29. Still, man, we're almost into Illinois. We are into Illinois. 42.29. And now we got to go minus, oh, we're really close now. $2,927, so 2,927, 40.43. Okay, there we are. So here's that water treatment plant. Oh, there's the untitled place mark. I did find it. It was right there. Okay, so there is our launch. So now we want to say it's important to know where you want to land, is what I'm getting at here. So let's say we wanted to land in field number 5. Okay, so now we're going to go back to RockSim, and we're using the Mako now. So where you go in RockSim is you go here to the uncertainties. So what we're going to vary here is wind direction and launch angle. So I'm going to set everything else to 0. I'm going through all these columns. Okay, so here's wind direction and launch guide angle. So I'm going to change 0 out everything else. Okay, so now the wind direction, we know we had a north, so north in here is up here, so the wind is coming like this, and we want to land there. So our wind direction can vary, let's say it can vary up to 10 degrees. And our wind velocity, we don't want it to vary at all. And our launch guide angle, we can vary the azimuth 20 degrees and our elevation 5 degrees. Okay, so that is what we're going to vary. And first I need to set my original starting state. I want to try to at least get close. Since I'm launching here and I need to land here, so let's say if I angle my rod towards the west, so this is my azimuth angle towards the west, and then I want to give it an angle of, let's start at 6 degrees, 6.6 degrees. So now I'm going to go back to uncertainty. So my initial setup, and then let's run this simulation. Let's do it 20 times, not 120. We'll start it with 20 and then see if we need to go more. And then hit launch. Okay, so it's going to run 20 simulations. I'm just seeing how long it's taking. It's going actually pretty fast. Okay, so now it's run the simulation, And then I'm going to come here to this button, and these are our landing points. And I'm going to say, let's export this to Google Earth. And it just exported it. And it's right here. Oh, look at this. So there's the launch point. And these are all the landing. We ran it 20 times. Here's 20 different landing points. And we wanted to land in field 5. So the closest one was either number 16 or number 20. So in number 20, it tells me right here, my launch guide should have been at minus 121 degrees and an elevation of 20 degrees. And it also tells me what the wind direction was. So if I take all these numbers, let me take a screenshot of this. And I go back to RockSim. I need that screenshot. Where did that screenshot go? Where's my desktop? Okay, so here's my variables. And if I go back here, this time I'm going to turn uncertainties off. So I'm going to make that 0 uncertainties. And then I'll just try to land at that point. So here, I needed an elevation or an azimuth angle of minus 121.38. Minus, I gotta move this off a little closer so I can see it. Minus 121.385. And my launch guide from vertical should have been 20. Boy, this is really cranked over, 20.323. And then my wind, on my wind table, I'm looking here on the wind table, at 800 feet, we have a direction of minus 14 and minus 17. So this one, I'll just make this one minus 17. Minus 17. And then the wind speed was 23 miles an hour. Holy cow. 38. Let's see what it looks like. This time we're running a simulation in RockSim Pro. Let's see if it thinks we should be landing there. Somehow I don't think it's going to land there, but we'll take a look. So it takes a little bit more effort to vary conditions to try to get it to land where you want it to land. Okay, so remember, so north is now straight up, and you can see that the rocket is angled this way. It's more than, holy cow, yeah, it's a lot more than angled to the west. Angled to the west would be over here. But we were trying to land over, I think, down here or here. Okay, so we launch. The rocket's taken off. It does not stay in the air very long. Thunk. Oh, the parachute did get out. I thought we were going to hit the ground. Okay, so if we look over here on this one, so we were angling at point number 20. Yeah, we actually got pretty close. I don't know if you can see that, but here's point 20 is kind of like in between 5 and 6. And yeah, we got actually pretty close. So basically, so that's how you would do it. You would run uncertainties to get to where you want it to land. And then you have to get your conditions that way. Now, if you didn't want your wind to vary at all, then you have to go back here into RockSim Pro. Come on. And go back under uncertainties. This time, you know, my wind is not going to change and my velocity is not going to change. The only thing that I'm changing is my azimuth and my elevation. And this time when we run the simulations and click launch, so while it's doing that, I'm going to clear out these because it's going to overlay this on top of it. I want to turn this off. So the next time we see this, and if I hit plot my points, the Google Earth landing chart, come on. And then if I turn on the points, there we go. Okay, so this time I've only varied my launch angle and direction. The wind is not varying. So now to get to field number 5, I would use the, click on this, I would use these values, minus 103.435 for the azimuth angle and my elevation at 20.98. So it's still cranked over pretty good. What's the NAR? I don't know if that would be legal under the NAR safety rules. Hood's News writes, I guess I'll buy some more glue to get software so my granddaughter doesn't cry when her rockets get lost in the trees. Yeah, this is exactly why you want to use RockSim Pro. Aren't there rockets, D. Hagen writes, aren't there rockets that take 13 millimeter motors and that are made for free fall recovery? Yeah, you could get away with that. The Birdie would be a good rocket for that. So if I go to the Apogee website and type in Birdie, this is a novelty kit. I think it calls for A10-3. Basically what it's going to do is kick the motor out, but even if it doesn't kick the motor out, it'll still free fall. D. Hagen writes, the 30-day free RockSim Pro vouch code is only good for one computer, right? And that's right. You can only use it on one computer. I had it on my laptop, but my 6-year-old son wants to play those simulations on his little laptop. Well, what he would have to do is buy $30 worth of products. We only allow it on one computer. So you could deactivate it on your computer and then reactivate it on his. To do that, you go to the help menu and then go to product activation. And it brings up this screen, and then it says, there's this button here that says deactivate RockSim Pro on this computer. When you click that button, it's going to deactivate the code. But now you have the code, so now you can go to the other computer, and then you would click on the button that says activate. You know, this button right here, activate RockSim Pro now. Since this computer that I'm on is already activated, that's why it's grayed out. But on the other computer, it won't be grayed out. But yeah, you can only run it on one computer at a time. Oh, we're past 3 o'clock. I hope I got all the questions answered. Thank you all for being here. It was lots of good questions again. I went really fast through the uncertainties. And so if you would like to see that again next week or the next time, next week we will not be here. I am traveling, but the following week I will be back. So next week I think is the 6th of February. So then 6 and 7 is 13. So the 13th we should be back. If the 13th is the Friday the 13th, I'll be back. Whatever the date is on the 13th. I'll be back, and then, you know, if we didn't answer your question, ask it again. And hopefully we'll get everybody's questions answered then. So thanks again for coming. I'll give you a countdown. And if you're launching tomorrow, I hope it's a great launch. I know some of you people, like Carlos in Marietta, Georgia, he's between snowstorms or bad weather. I don't know if you're getting snow or not. Yeah. If you're launching tomorrow, I hope it's a good launch. Our next launch is next Saturday, and I'm going to be missing that because I'm going to be gone. But I hope you have a good launch. So in 5, 4, 3,